Hola, buenos días a todos. Le damos muy cordial bienvenida. Les recordamos que por favor silenciar su micrófono durante la ponencia y todo el evento, apagar sus cámaras y enviar sus preguntas por mensaje en el chat que vamos a leer al final del evento. Los pueden poner igual en inglés o español, lo que les agrade mejor. Y si tienen algunas sugerencias o comentarios, siempre pueden contactar con nosotros en el siguiente correo que ven en la pantalla. Le damos muy cordial bienvenida a un montón de países hoy. Reino Unido, Costa Rica, México, Chile, Perú, España, Estados Unidos, Guatemala, Bolivia, República Dominicana, Alemania, Colombia, Argentina, Ecuador, Honduras, El Salvador. De verdad es excelente ver tantos conectados y interesados en el tema. Les vamos a introducir muy en breve SFPE capítulo México, nuestros objetivos y la misión del capítulo. Vamos a escuchar la presentación del ponente del hoy, doctora Lynn Halls, que nos va a presentar, hola Lynn, que nos va a presentar Modelado de evacuación y cómo puede ayudar a construir un futuro más seguro. Y vamos a ver las preguntas y tener la clausura del evento al final. Les recordamos siempre, y los que son nuevos en conectar con nosotros, que nuestra misión es promover el uso de las mejores prácticas de ingeniería, fomentando la educación y capacitación de la seguridad contra incendios en la sociedad. Y tenemos objetivos como fomentar el uso de la normativa nacional e internacional en la sociedad y en especialistas en protección contra incendios, profesionalización de las personas en la ingeniería contra incendios en México y difundir la cultura de la protección contra incendios. Nuestra ponente hoy, doctora Lynn Halls, es una persona muy especial, para mí especialmente, ¿no? Porque ella, además de todos sus logros, fue importante en mi vida en que fue supervisora principal en mi tesis doctoral. Muchas gracias, Lynn, por toda tu paciencia, todo el tiempo. Pero lo más importante es la doctora Lynn Halls es una investigadora experimentada en el Grupo de Ingeniería de Seguridad contra Incendios, EFSEC, interdisciplinario y, bueno, que se encuentra en la Universidad de Greenwich, Londres. Como psicóloga colegiada, su investigación se centra en cómo las personas responden en situaciones que presentan una amenaza para la vida. El conocimiento y los datos recopilados ayudan a aumentar la comprensión de cómo las personas perciben, procesan y actúan en torno a los peligros. Además, ayudan con el desarrollo de las propias herramientas de software de simulación y modelado de evacuación de EFSEC, por ejemplo, así como la suite de Exodus. Estas herramientas son utilizadas en todo el mundo por profesionales responsables de proteger la seguridad pública. Los ayudan a investigar, planificar, prepararse y responder a una variedad de incidentes de emergencia. Lynn, with this, back to you, and we're looking forward to your presentation.
Thank you, Sandra. I'm just going to share my screen now. Okay. Welcome, everyone, and thank you very much for attending today. As Sandra said, my background is as a chartered psychologist, and so my research with EFSEG is to investigate human behavior in situations that pose a threat to life. And one of the applications of the knowledge and data that comes out of that research is that it can help develop models of emergency evacuation. And so what I'm going to be talking about today is the use and the benefits of evacuation modeling when looking at fire safety in the built environment. Before I go into the crux of today's talk, there's a couple of things that I think is worth just mentioning. It's probably things that you're very familiar with already, but just in case you're not, I just want to go through a few key terms and also caveat before we begin. ASET, the available safe egress time, is how long, if there's, say, a fire in a building, before the conditions become untenable. Now, the user can come up with what they want to mean by untenable. It might be heat that gets beyond a certain temperature that is too much. It may be the toxic properties of the smoke that's spreading that starts to make people become unconscious and so forth. It's up to the user. But the calculations for ASET, they can be done in different ways. And one of those is fire modeling tools. And what the fire modeler can do is they can look at some probable scenarios of the fire as it grows and spreads throughout the building. They may also want to then run scenarios of a lesser or a greater severity, and then that gives them a range of times for how long it is before the conditions become untenable. And so then you end up with a calculation for ASET. For RSET, that's the required safe egress time. And so basically that's the amount of time that's needed to get everyone out of that building. So basically that time ends when the last individual exits the building onto the street. Now, again, it can be calculated in a number of different methods, but evacuation modeling tools can be used here and can be particularly useful if a building is quite large and complex. And the evacuation modeler will again run several scenarios, looking at best case scenarios to get the shortest possible RSET time, the worst case scenarios to get the longest RSET times, and then therefore you end up with two values. The first ASET driven by the fire behavior, and as I say, can be calculated with fire modeling. RSET driven by human behavior and can be determined by evacuation modeling. And what you want, and I hope you can see my cursor, is that you want RSET plus a safety factor, which is just basically a margin of error, altogether to be less than ASET. So basically the required time it takes to get everyone out plus a margin of error should be less than the available time until conditions become untenable. If that's the case, then you can consider that building to be safe. However, the caveat I'm going to throw in here is that the fire modeling and the evacuation modeling, I've got a couple of stills from each here, are often conducted independently. Now, in real life, there's going to be an interaction between the fire and the humans. When they encounter fire cues, the humans are going to react quite often first by investigating those cues, which may mean that they approach the source of the fire rather than immediately start escaping from it. Also, the products are going to affect those occupants. They can affect their visibility, which means that they may have difficulty finding an escape route. They can affect them physiologically in terms of have difficulty breathing. They may want to get down low to the ground, so their movement speeds may become slower. And as a result, RSET could be higher than might be anticipated if they were conducted, the analyses were conducted independently. So what can be done, a solution to that, is coupled analysis. Now, as Sandra mentioned at the start, FSEG produces its own software. Exodus is the evacuation modeling software. SmartFire is our fire modeling tool. And because we developed them, we've developed them in a way that they can basically talk to one another. So what happens is you would start with fire modeling, as per usual, but then you can import the simulation data from SmartFire, or indeed other products such as CFAST, into Exodus. And then the agents in Exodus are going to be doing their evacuation at the same time as the hazard is progressing through the building. So I've got a few stills here. In this first one at the top, that is a building where the evacuation has begun. The fire hasn't really spread much yet. At this point, the areas that are colored in is actually where the hazards are now, that's where they've spread to in the fire modeling. And as you can see, the agents are now moving away from those hazardous parts. And then towards the end, unfortunately, as the smoke has spread throughout and the conditions have become quite untenable, a number of the agents have now expired because they've been exposed to that danger. So the benefits of this is that Exodus can not only tell you how long it's going to take people to navigate their way through the physical environment and get out, but it can also give a report on, for example, the injury levels that the evacuees are experiencing and whether they might survive or not. And as a result, you can get greater realism from coupled analysis as you might get from independent analyses. So that's just a caveat I want to throw in. Evacuation modeling and fire modeling are both fantastic tools, but like with any kind of method, there are some limitations. And so there does need to be work done to try and overcome those. So with all that in mind, let's turn to today's talk. In 2017, in the UK, there was a very tragic fire, Grenfell Tower. It was a high-rise residential building, and the fire was rather disastrous. 72 people lost their lives in total. Many more were injured, and many more again were actually traumatized, those both in the building and those witnessing it. As a consequence, the UK government commissioned an independent review of the building regulations and fire safety in the UK. And this was carried out by Dame Judith Hackett. And in her final report from that, she said that through the life cycle of a building, it is essential to provide not only reassurance, but more importantly, evidence that a building has not only been built safe, but it continues to be safe throughout its life cycle. And because there are many different people involved in the life cycle of a building, that means that the actions of many different people can compromise the integrity of the fire safety of that building. So there's a great amount of potential for human error and human failure to impact at various different points along the life cycle. Hackett also criticised the industry as a whole that's involved in buildings, saying that it really hadn't reflected upon and learned from past mistakes in itself, nor had it looked to other sectors for ways in which it could be better. And moreover, she criticised it for being an excessively fragmented industry. Now she's talking about the UK industry. I'd be curious to know if that's the same in the other countries from the people who are attending today. But certainly in the UK, there's been a number of problems, and therefore there's a lot of things of action that has to be taken to counteract that. So despite all that excessive fragmentation, I'm going to at least try and bring together some of the work that FSEG has been doing across the different phases of a building's life cycle. I'll be starting with building design and talking about some concepts such as BIM, building information modeling. I'm going to move on to the building construction phase. I will then talk about the phase where the building's occupied and in use and look at some internal threats. And by that, I mean fires that start inside the building with two examples. I will then look at external threats. So these are ones where something from outside impacts the building and causes fires within it. And for that, I'm going to use an example of 9/11. And then I'll be looking at cases where it's not just a single building that we're looking at in terms of fire safety, it's fires that can affect a much wider urban space. And so I'll use the example of wildfires there. And then if we've got time, I'm going to just quickly talk about a couple of issues related to reliability and validity of the data that's used in this type of work. So I'll start with building design. And just down the side, on some of these slides, you'll see some publications that FSEG has produced. I'm not going to have time to go into detail on this work in this talk. So I really would recommend if people search out the original publications and have a read of the full text, please feel free to contact me. I can share the slides or even share the actual papers themselves if you're wanting to have a look there. So building design, that involves a lot of choices. And those choices will tend to be motivated by a variety of different factors. Function of the building is an obvious one. Aesthetics, cost, most certainly will drive building choices at the design phase, and also safety should be in there too. However, the choices made around the design of building are not always done so in a holistic manner, nor is timely consideration given to how changing one thing, say deciding to reduce costs, might impact some of the other factors, such as safety. Now, Judith Hackett pointed that out in her report. She recommended that building information modeling be used. That has now become mandatory. And this building information modeling, or BIM, can help inform the choices. It does so by basically, there has to be a digital representation created of the structure. And it's not a static representation. It will be updated. Therefore, it's dynamic. People can see how the changes will look. but also because that representation is shared with all the stakeholders who have a duty to be responsible for the fire safety of the building, they can see how some of the original choices or even some later changes such as refurbishment and renovation can impact some of the other factors, hopefully before the building's actually made or before the changes are made. And therefore, if there are some implications for, say, safety, they can be spotted in time. But then how does fire safety fit with BIM? Because it's a very good intention to bring it in. It definitely needs to be done. But what are the practical issues? Now, fire and evacuation models, as mentioned earlier, they can simulate a number of different scenarios to reveal some vulnerabilities within a building, to highlight some safety risks. But the question is, how does the data get shared between BIM and those models? This is what one of my colleagues was looking at for his PhD research and some ongoing research, Sim Siddiqui. And he developed a prototype system that could evaluate data sharing between BIM and two fire safety modeling tools. That was our own one, Smart Fire and Exodus. He subsequently done work with some other collaborators, and they've used Pathfinder, an open source modeling tool. And all that work has determined that, well, basically there's a number of challenges that need to be dealt with currently. First of all, in terms of what can come out of BIM, that is somewhat restricted to date. Now, building geometry is one of the things that can definitely be taken out, but some of the limitations around others is largely down to file format. There's the lack of compatibility between the different tools. Even the data that can be taken out, such as the building geometry, often is in a form that isn't necessarily great for use within fire and evacuation modeling. So oftentimes they'll have to clean the geometry before they can use it. But then it can be used, and they can get results for A set and they can get results for R set. The biggest problem that they're currently facing is then how to get those results back into BIM. Again, format compatibility issues is a problem with the files. And so at the moment, there's only a one-way exchange of data. So the fire and evacuation modelers can do some analyses to look at the fire safety of the building, but what they can't really do very easily is get that information back into BIM so that the other duty holders are able to view it and understand the ramifications of the choices that they're making. And so that is something that definitely needs more work. And indeed, ASIM and others are working with Building Smart to try and get some standards around that so that there can be some progress in this area. I'm going to move on to building construction now. Construction work is one of the most, if not the most, dangerous professions in the UK and in other countries in the world, largely because of working at height. So there's a risk of people falling. There's also a risk of other things falling onto people. Because of the dangers, or even in spite, one way or the other, there has been a recognized need to create a safety culture in the construction industry. And that was something that actually Hackett spotted and praised in her report. Now, it's assumed that if there is a positive safety culture, i.e. the policies and practices on site are geared towards making things safe and everyone's invested in that and goes along with it, then there should also be a positive safety climate. And by that, I mean, if you were to stop a worker and survey them and just say, okay, what level of risk do you currently perceive in terms of injury or death when you're working on site? You would expect them to say a very low risk if there's a positive safety culture. But that's still sort of under question. Another question is, do the dangers of construction work foster or attract those people who have an appetite for taking risks? Because obviously if it does, then that will jeopardize the safety culture. What was another question that I feel is really one that needs asking is, where is fire safety in the literature on safety culture and safety climate? That is a vast body of literature. There's a lot out there and it's been done for decades and it will continue, I'm sure. But I challenge you all to go and look at that literature and try and find mention of fire anywhere in it. I tried it and I could count the number of instances I found the word fire in there on one hand. It was a very low mention, very little attention given despite the focus on safety. In the UK, a further issue we have is in our national fire statistics. If you look at, for example, the Health and Safety Executive documentation and other sources, they will mention that there are a number of construction fires that happen every year in the UK, but you cannot actually find the statistics. The national fire statistics do not actually specify construction site fires as opposed to fires in occupied buildings. They don't separate them out. So it's very obscured. As a result of that, another group of researchers had to put in freedom of information requests to the different countries with fire services. And they found that there was at least 500 to 600 identified construction site fires every year in the UK, some of which included reports of casualties. And that's very much likely to be an underestimation, just because there was difficulty even getting the data out of the ones who did respond. As a result of all that, we felt at FSEG that this is an area that really needs more attention. So what we did is we teamed up with IOSH and also a global construction firm, Multiplex, and we carried out 2 unannounced evacuations at a couple of high-rise building sites, which I'll just call 100 BG and 22 BG. And what we did was we sounded the alarm, and the workers were not aware that this was going to happen, but they should follow the protocol of evacuating the entire site. We had some GoPro cameras fixed discreetly around the site so that we could video record the behaviours. We also surveyed workers after they had completed their evacuation so we can get some self-report data. And then after all that was completed, we ran some further trials with the construction workers on site where we had them walk over different surfaces, concrete, rebar, so forth. And also we had them descend down different types of means such as ladders, temporary scaffold, stairs. And we videoed the performance and measured it. Now, what did all that work tell us? If we start with the self-report data, it was actually looking really rather good. We found evidence of a positive safety climate on both sites. We found little evidence of the workers being risk takers. Almost everyone heard the alarm on the days, and the majority of them believed that it was a real emergency. We looked at certain subsets of the workers who might be considered vulnerable. So these were younger workers, migrant workers, and we didn't actually find any evidence of them being disadvantaged. And by that, I mean, most of them heard the alarm, believed it was real. They could also recall the emergency procedures that were written down and had been briefed to them when they started. But the one thing that was problematic was that around half of the sample said that they did not evacuate immediately. And that's what they're supposed to do upon hearing the alarm. And when we looked at the video data, that confirmed that a number of workers do not respond rapidly. In this instance, we were finding up to 6 minutes before they completed doing what they wanted to do. In some cases, actually, a supervisor had to come over and physically kind of wrestle them away. So yeah, definitely there's ones who are not responding rapidly. And then we also looked at the data from the trials that we conducted subsequently. And we found that, yes, the workers do move more slowly across different types of floor surface, such as rebar. They do move more slowly down means of descent, such as, as you can maybe see in these pictures here, ladders, which are positioned right up here at the top. And also these temporary scaffolding stairs, much slower moving down these two than they are down completed concrete stairs. But that poses a question because there is now a growing interest in using evacuation modeling to look at construction site evacuation, but most people will probably be using data from buildings that are completed. So where they are moving around on more solid surfaces such as concrete. And that means that our set might actually be underestimated. So what we've done from this project is made the data available as a validation data set. So if anyone is interested in using that for construction site evacuation, please do get in touch. Now, if we look at internal threats during the occupation and use phase, All the examples I've given just beforehand, we've been looking at predicting what might happen in a fire in the future. But here we can use evacuation modeling along with fire modeling to do forensic analysis of fires. So investigating what happened in fires that have already occurred to discover what caused the fatal outcome, and more importantly, could any of the deaths have been avoided? First example I'm going to talk about was a fire in Korea in 2009. It took place in a shooting range, which was situated on the second floor of a multi-story building. Now, the problem there was that the walls and ceilings were covered in a type of material that was designed to dampen the noise, which it did, but it lacked fire resistance. A further problem was that gunpowder residue had been allowed to accumulate on the walls and ceilings. As a result, you have quite a flammable environment. Now, it's believed that the fire was likely caused by a stray bullet that actually struck one of the walls and the gunpowder residue ignited. And so what FSEG did was we carried out a coupled fire and evacuation analysis. And the first question we looked at was, could all of the deceased have survived if they'd started evacuating sooner? So the fire modeling was carried out first, and this is just a still taken from it in the first, I think, 3 seconds. This is the burnt area already. And what you might be able to see here, this is a doorway, which is the only exit route from the shooting range, leading out into other parts of the building. And as you can see, it's already warming up. There's already some burning going on there. By 11 seconds, so we're still talking very, very early on, the fire modeling shows that this area is now covered in smoke and visibility is very poor. So the whole range plus this area that escape route is going into. After that, we took the simulation results, we put them into Exodus, we ran Exodus, and this is what we came up with in terms of where we thought the people would end up. And as you can maybe see here, we predicted 1 survivor from all of that. Up here is a map where the actual people were found at the end of the incident. And if you can see here, 4 people got out, but 3 of those did not survive their injuries. Only 1 person got out alive, which is what the modeling had told us as well. Whoops. And so it gives quite good results when you use this kind of modeling. Now, could all the 15 have survived if they started evacuating sooner? No, unfortunately not. The evacuation and fire modeling showed that basically the escape routes were compromised very early on. So the likelihood of being able to survive that was very low. Second question, could the fatalities have been avoided if the walls had been cleaned of the gunpowder residue? Again, the modeling was run this time with areas not so flammable, and indeed, yes, fatalities could have been avoided if the walls had been cleaned. So modeling can really help investigate some of these past incidents, which is why we also then went on to use it for Grenfell Tower inquiry. Our director, Professor Ed Gallia, was appointed one of the expert witnesses, and so I was part of the team that was helping him on that. Now that fire, as I said, happened in the UK in 2017. There was a fridge that started to ignite. It was an electrical fire in a kitchen of a flat that was on the 4th floor of a 23-story building, high-rise residential building. Now the firefighters got to the scene. They were able to extinguish the fire pretty easily actually in the kitchen, but unfortunately by the time they arrived and did that, flames had already escaped through a kitchen window out onto the facade of the building. Now, just a year or so earlier, the building had undergone refurbishment. Some new cladding had been installed with materials listed there for rain screen installation. Again, thoughts were based around function and cost. However, the cladding material lacked fire resistance once more. As a result of that, the fire quickly spread up, around and down the outside of the building. And as it did so, it broke into other flats and ignited their contents. Because of that, thick smoke then spread from the flats into the communal hallways, which was the escape route. And also that escape route led onto a single stairwell, which was also compromised by smoke. So what we wanted to do was work out whether all of the deceased could have survived if they started evacuating sooner. And just in brief, the answer is yes, very much so. Now, where I say if they started evacuating sooner, I think that implies perhaps that I'm saying that the occupants were slow to respond. That's not necessarily the case. Actually, a number of occupants, as soon as they received fire cues, were on the phone to the emergency services, and the call handlers were not able to see basically the devastation that was happening on the scene. They were not able to get that information early enough. And as a result, they advised the people to stay put. And stay put is even to this day, still the main method of strategy that's put in place in high-rise buildings, i.e. if your flat or the area that you're in is not directly affected by the products of the fire, you don't evacuate. The idea being that you would get in the way of the firefighters doing their job. However, if compartmentation fails, which is what stay put relies on, then it can be disastrous. And that's exactly what happened in Grenfell. The doors to the apartments were not necessarily fireproof. They were letting smoke in to the people who were already sheltering in their flat. They obviously couldn't go to the windows to get air because the fire was raging outside as well. The ones who did manage to evacuate, whenever they opened the door closing mechanism was faulty on a number of them. So the doors weren't shutting properly, which meant the smoke that was coming from outside or the fire starting inside were then spreading into the communal spaces, meaning that other people then couldn't open their front doors to get out. It's really an example of all the sorts of things that could go wrong, that did go wrong, and very much highlighted how fatal the consequences could be. Could those fatalities have been avoided if the fire had not been able to spread across and throughout the building? Yes. Again, if those mechanisms had been in place, if they had been maintained properly, also the firefighter activities, sometimes they were plugging the hose in on a floor different to the one they were actually doing the firefighting on, which meant that the stairwell door on a number of floors was being left ajar by the hose. The fire hose was keeping it open, meaning that smoke was spilling out into the stairwell and making evacuation descent difficult for other people higher up. I'm going to move on to external threats now. And as I said, I'll talk about 9/11. Now, it's a terrorist attack, obviously, and it's something that people of my age in the UK are quite familiar with because we grew up around the time of the Troubles in Northern Ireland with the IRA bombings plural, I should say. In those days, the perpetrators tended to try and keep clear of the actual blast that would start a fire. And these explosions were taking place in buildings that were highly populated, such as hotels and pubs and so on. Over time, the modus operandi of terrorists has evolved, or one might argue regressed, in that we've now seen an increasing number of suicide attacks where the perpetrator actually carries the explosive up to the building, either in a vehicle or on their person, and they die along with the other victims. And a couple of examples of that is the 1983 US Embassy bombing in Beirut and the Manchester Arena bombing in the UK in 2017 during an Ariana Grande concert. 9/11 stands out from all of those still because they didn't create an explosive device. They took some everyday objects, passenger jets, filled with people and filled with fuel, and flew them into the World Trade Center. As in other types of explosive attack, that caused a lot of structural damage and there were a lot of fatalities that occurred upon impact. But the damage and the impact, the fatalities rather, were not confined to the area of impact because the spray of the jet fuel spread. It caused fireballs to shoot up and down the elevator shafts in both buildings, and that meant that there were multiple fires across multiple floors. Despite all of that, quite a number of people still managed to get out alive. And so we wanted to know how. We wanted to learn from this. And so the very first project that I was involved in with FSEG was going out to New York and interviewing survivors from the North Tower, the South Tower, and the low, mid, and high floor regions within those towers. What we found from that was that the survivors from the South Tower were more likely to have been rapid responders. And by that, I mean those who started evacuating almost immediately within the first minute. Rapid response was only predicted by two variables: perceived risk, so a higher perceived risk, faster response, and also the number of response tasks undertaken. So after the first plane flew in, those who then undertook more tasks, such as packing up their desk, calling friends and family, and so forth, were the ones less likely to leave early and therefore less likely to survive. Now, in amongst all the data we collected, the analysis that we did, we noticed that the descent speeds were slower than expected. And so during the interviews, something else we'd also done was we asked about the conditions in the stairwells. And to help understand what we were being told, we showed the participants some animations that we used we created them through Exodus using the Fruin level of service, so that each one showed a different density and a different flow rate. And whenever somebody said something like it got really busy at that point, or it was actually quite empty when I opened the door, we could show them these and say, well, which one of these best represents what you're recollecting there? We then put that into the modeling, and then we found out that basically why the descent speeds were slower. Now, we had hypothesized that fatigue was playing a part here. These are 110-story buildings. That's a very long way to come down. And we thought fatigue was maybe responsible for that. And actually what the modeling showed us was no, there was actually just a congestion that was stopping people. The number of people in the stairwells, also remember firefighters were using the stairwells to come up as well. Now, in modeling, usually we believe that once a person's out of the building, they're safe. Well, we don't believe it, but that's the assumption that's made in modeling. However, in an incident like this, when people came out of the building, they then had some further jeopardy. There was falling debris. In some cases, there were falling bodies. And then, of course, the buildings themselves collapsed, which is not normally something that would be considered and looked at. So that brings me on to post-exiting behavior. It's another term I'd like to just bring in briefly. So we're talking about the behavior that happens once people are out of the building, but not necessarily yet at a place of safety. The evacuation will continue beyond that. And as a result, we, in the field of fire safety and evacuation modeling, we need to really start thinking more about identifying, quantifying, and modeling further agent behaviors. This could be the dispersal of people or the assembly of people in close vicinity to the affected building. We can also look at the behaviors once they get to a place of safety, and that might be based on the type of place, whether it's a building that's designed as a refuge or whether it's an open space. Obviously, some people might decide to head home, but heading home might not be heading towards a place of safety. And one of the reasons they might do that is because they want to join up with others. So we need to look at group behavior as much as we do at individual behavior. On top of that, we need to look at vehicles, because up to now, we've only really been looking at pedestrian evacuation. And so we need to look at vehicles being used as a mode of transport to get away from the scene of danger. But we also need to look at pedestrian and vehicle interactions. Now, again, there's a vast body of literature out there on pedestrian vehicle interactions, but that comes from just the typical road safety literature. So we need to look more at behaviors in terms of how people cross into a street where traffic might be oncoming. And we also need to look at movement of pedestrians when they intermingle with the traffic, when they're moving in the same direction or maybe going contrary direction to them. And of course, there's going to be a sense of urgency in these interactions, particularly from the pedestrians, but also maybe from the drivers as well. Now, because we know that's an issue, we've started looking at it. So before I talked about coupling evacuation models with fire models, here what we've done is we've coupled Exodus evacuation model with SUMO traffic model. And on the left, we've got a still where you can see we no longer just look at people coming to the perimeter of the building. We also look at them coming outside. Some of them are using an actual designated crossing. Some of them are spilling across the road. And here are the vehicles. Now, I'm just going to quickly say that obviously the graphics in modeling can vary to whatever level of fine detail you need them. So sometimes given the computing resources required, you may just want to have some dots representing people and vehicles. Sometimes you might want these rather kind of pin-like 2D representations. Sometimes you might want to put it into VR software and get some 3D modeling out of it. It's up to you. And obviously, again, that's an area where more development is ongoing. But yeah, that's the Exodus now interacting with vehicles. And then because it's a two-way sharing of data, you've got in Sumo, the vehicles are now reacting to the presence of the pedestrians and what they're doing. So in this case, the vehicles are slowing down when they encounter pedestrians who've crossed out in front of them into the road. So this kind of thing can increase the realism of the scenarios that are being modeled. It can also give an idea of whether our set is being underestimated, overestimated, or in the right bracket. We can use this to look at how the evacuation flow is from the structure going out onto the street. But we can also look at if there are some bunching up of pedestrians because vehicles are there. We can look at whether that has a knock-on effect back into the building, stopping people getting out through the final exit. And of course, that'll be of interest to emergency services because the fire service will be of interest to people being held up in the building. The police will be of interest to this because of their involvement in managing traffic. And I've just highlighted a couple of work here, one by some colleagues who looked at crossing behavior. They did so, it was still in a kind of more normal traffic situation where people were in a hurry to cross the road to get to something on the other side. But they talk about potential applications to evacuation modeling. And then one for myself, I was looking at some work with autonomous vehicles, and this was in a shared space. So we're able to look at crossing behavior at an undesignated crossing, but also passing interactions where the pedestrians were traveling along the same route as the vehicles, either head on or one approaching the other from behind, and what happened there. So there are ways in which we can try and get some data on pedestrian vehicle interactions, but as I say, these are a more, okay, autonomous vehicles is a more unusual situation for them at present, and this was did cover urgency, but how much can that be generalized to emergency situations is the question. So this is definitely an area where more work and collaboration will be much appreciated. Okay, now another external threat that's quite relevant here is obviously wildfires. And so what we've been doing with Exodus is we've been coupling it not only to vehicle models such as Sumo, but also to hazard models for wildfire, because SmartFire works with fires in enclosed areas. So we've worked with other tools that can model the fire front, that can model smoke plume and so forth. And this is really needed because obviously, as you'll all be aware, I'm sure that these kind of large scale incidents, they're becoming much more frequent and much more intense. And so the people involved in the crisis management really need some help in planning for and preparing for these types of disasters, but also what they really would like is some models that can operate real time so they can help them as they're responding to the emergency. There is a number of challenges with that though, because there's a lot more data inputs required to set these up. Some examples are listed down the right-hand side. So you need data for the geographical area from things such as the Ordnance Survey map. The structures, which normally would have been modeled in great detail, now have to be turned down to coarse nodes. You want to model both the exits from the buildings, but also assembly locations, which could be located quite a distance away and of a different nature. You need data from the local authorities and fire services in terms of population. Where are they likely to be located at different times of day? How many own a vehicle that could be used in evacuation? And so other things such as also notification methods. Some countries are more advanced than here. We had a test recently where they sent out a text message, and I know I didn't get it on my mobile phone, and I know lots of other people who also didn't get it. But there are, I know, other countries who use this more, they're much more advanced in getting much better systems working out there. But other times it may just be going door to door, knocking on the doors. So it could take longer to notify people in the first place. Some procedures will be very much geared to evacuation. Some will be geared to keeping people in place. So a lot of differences and a lot of things to take into consideration there. However, once things are put together, they can be done to not only look at wildfires, but also cascading events within such disasters. So in this particular example, the group had people starting evacuation from a wildfire, but then because this was on the road network, they had some accidents occur where some of the vehicles collided. And in this case, the truck was actually carrying something that was really flammable, and that caused a sort of secondary incident that people had to be evacuated from. But the data can tell you, as before, how long it takes to get people out and also exposure to the hazards. Just take a bit slow, there we go. Some other research I'm bringing up, you might already be familiar with because the president of your chapter is involved in this. What she found from her PhD work, which is published, and these are just a couple of examples, is that oftentimes in wildfires, there seems to be a sense of seeing is believing. So if you are faced with kind of definite signs of a fire, such as flames and so forth, then people are more likely to react to that than maybe some more ambiguous signs, or even if there's no environmental cues, but it's social cues. There's a number of different times it takes to respond to people to the different types of cues. Also, because people are in evacuation of wildfire, they're not able to return home for quite some time. They're also not going to be able to protect it while they're away. So the question is, what do people do once they are aware that there's a fire and they know that they maybe need to evacuate? And so some of this research looked into the types of behaviors that people will undertake, and also the types of times it might take them before they start the evacuation. And of course, all of this has implications for RSET, which might be rather different than from a single building fire scenario. And it's really important that what we find from this is that the public need to be educated just as much as the practitioners and policymakers. And we're actually trying to get a project going where we can run the models in an environment where the public are present, so we can show them some examples of scenarios and give them an idea of, if you were to undertake all of these things you thought you were going to do, you don't necessarily get out as quick as you might think you do. And obviously that can help educate the practitioners and policymakers as well. And I know Sandra has very recently published some work that's specific to Mexico, so I do recommend people looking up that work as well. Okay, I'm going to just quickly summarize what these last few slides are saying. The reliability and the validity of modeling is based on, can we trust the output? But also, for that to be the case, we have to trust the input. And if we think about the output, one of the most frequent questions that comes up is, how many simulations do you need to run before you can be sure that the results give you an accurate representation of all the sort of variations of behavior that could occur? Now, the literature has shown that in some cases, some people have only run as few as 10 simulations. In other cases, we've heard reports of people running 2,000 simulations, which is incredibly resource intensive in terms of computational resources and time. Can people really be justified in doing such a low number or such a high number? Well, one of my colleagues, Angus Grandison, he looked into that, and he was looking at a method where you look at convergence. Now, other people have done that too, but the question that then comes out of that is, how do you determine what is suitable convergence? And so he ended up coming up with a method that you can just see here. Unfortunately, that's not too hard. I do recommend searching out his paper, because he does actually look into a way where you can run enough, and then once you see that there's convergence, then you don't need to continue on to do thousands more. As for the data input, as I said, we collect data from people, either through survey methods, through interview methods, and so on. But that often relies on human memory, which has often been mentioned is not the most reliable thing. Sometimes, I would argue, in cases where there's fear, as long as it doesn't go fully over into stress and then PTSD, it can actually help memory, which is something that isn't mentioned enough. A lot of that research is often done with threats such as guns and so forth, but obviously in fires, the threats are in the form of smoke and flames. And so what the investigators will do, they'll ask them to describe that. But really, how do we interpret descriptions such as there was a lot of smoke or the flames were quite big? How can you take that and interpret and ensure that your understanding is the same as the person who told you that, and it's the same as someone else who maybe describes it as a lot or quite big? So we had a knowledge transfer partnership earlier on with Kent Fire and Rescue Service, and in that we designed and filmed some mock kitchen fires. And then out of that, to test people's reactions to it, we developed just a really simple tool. This is just the smoke descriptors. We also had ones for flames. And what you do is you just basically have the size of the hazard relative to the size of a human. And then if they're describing it above their head, you can tell whether it's at a state where it's enough that they would still be outside of the toxic area and the hot gases, or whether it's now encroached into their head and shoulders region where they would be affected in terms of both visibility, but also breathing and so forth. And that way it can just help give you a better sense of what it is they're talking about. And those picture descriptors actually went on to be used in the Grenfell Tower inquiry by the survivors when they were given their witness statements. So to sum up, evacuation modelling, if it's combined with some robust research on human behaviour, can really help contribute to enhancing fire safety in the built environment across the life cycle of buildings and across not just single buildings, but looking at wider urban spaces. From our work, we've managed to identify gaps in the research. We've managed to generate strategies, knowledge, and data sets. That in turn has helped us develop modelling tools, which can be used to help predict and plan for future incidents, respond to present incidents, and investigate past incidents. And also, we always have to bear in mind that there has to be continual development of these tools. They have to keep being made better to ensure that their accuracy is as good as what we believe it is, or is made even better. And we're very appreciative to all the collaborators that we've had in that, not only the funding agencies, obviously, but the authorities, industry, emergency services, and very much so the public as well. Thank you very much for listening.
Thank you so much, Lynn. It was a great presentation, really, really informative. We have a couple of questions now in the chat, so I will go through them. The first one is from Jorge Herrera Cruz. He's asking if you've worked with your team on any analysis of a scenario that's based in Latin America, because obviously there's something that needs to be taken into account is the enormous differences between the construction and the norms that exist here.
Yeah, and certainly in terms of construction, no, we haven't done work in South America. At the moment, our work has been with the UK on that side of things. Some other modelling work has gone on for like occupied buildings or buildings that are about to be built in other parts of the world, but not in that. So definitely there are great variations, and that's why the fire safety community has to come together as a whole, because we really do need to understand how generalizable any of our data sets are to other countries and other cultures. So if Jorge knows of any, that would be great to get in touch and let us know.
Thank you. Another question from him is if you've worked or documented any analysis of modeling of evacuation for the informal or irregular human settlements. No.
Now that's an area I know other groups have. ARP, actually Sandra will be able to, to say a bit more about that. Yes, that is certainly an area, because obviously those buildings are not built to the same standards as we're looking at, obviously, in places like the UK. And so, well, as I say, you could probably tell more, because obviously collecting the data just in the beginning is a hard thing, getting access to these areas. And then also you came up with a methodology that could be used potentially in future to go ahead with that. But then there's a question of, if you don't have that data, how do you model? You know, again, you would have to work with a number of assumptions that might not be correct.
Yes, because obviously the data collection has to be very systematic, and the attempts that I know were the very beginning of just trying to see what could that systematic research or could that systematic data collection look like before we even begin to input anything into a model and try to run the simulation. So yeah, you're correct. It's still not really widespread, and it should. Right, because there's a lot of people who would benefit from this type of analysis. And one question from Francisco Zapeta. In Mexico now, we have a probability to use this sort of evacuation simulations, I suppose, with the increasing risk and increasing activity from the Popocatépetl volcano in Mexico City. Is there any, oh, actually there's an English version. So sorry, I'm just gonna track back and to read the one that's more easy for me. So now in Mexico, we have probability of using this type of evacuation with the increase in activity of the Popocatépetl volcano. There is some modeling for this possibility and how the authorities should handle it.
Yes, so tools like, for example, Urban Exodus I mentioned earlier that looks at wider urban areas has been designed not just for fire, but also flood, CBRN incidents and so forth. So other types of incidents where whole communities might be affected and need to be evacuated in time before things spread. Volcano is one that we haven't done yet, but it's obviously, as you say, in different parts of the world, that's very much a more urgent hazard that they're having to deal with. For the authorities to use that, again, what they really need to be doing probably first of all is just simply working out baseline, how long does it take people to get out? So a little bit like what I described at the start, when you do independent analyses of ASET and RSET, probably need to focus on RSET first, then the knowledge for ASET, excuse me, the volcano is going to, the behavior of that, they'll need the input from, is it volcanologists? I can't remember the exact term. They're very much going to have an involvement in that to let them know how the hazard spreads. So if they have data as to the type of area, the sort of fuels that it would need and what the effects of that would be, then modelers can maybe start to put that in and build up. But for the moment, I think, I'm guessing what they probably would have would be good for RSET, but ASET might take a bit longer.
Thank you. Fernando Hurtado is asking if this sort of modeling or something similar in relation to evacuation was ever presented as an idea to civil protection in Mexico, and if so, with what results. And he's also saying thank you and great presentation.
Thank you very much. No, Mexico is a part of the world that we haven't had so much involvement with so far. Actually, with Sandra going out there, that's been nice to hear, but because I know she's also done some work with things like earthquakes. So there's obviously different types of things that might be looked at. So no, we don't have any results and therefore impact from that part of the world that I could talk about. I'm curious though to know actually within the audience, you know, again, what work is being done there, because as one of the commenters just said that, you know, there is a potential maybe that some are using modeling. So it'd be really good to hear if it has been used, what has been the results so far in terms of disaster management.
Yes, if anyone has any thoughts, please put them in the chat in the meantime. We have another question from Ricardo Ortiz. What recommendations would you have for Mexico, considering the lack of adequate laws for the application of what you mentioned?
Yes, not just Mexico. There's kind of two ways of thought when it comes to fire safety calculations, and there's some who believe that we should really just follow what is prescribed by law. So they stick very much to the regulations and just say, well, if the regulations say that a building has to be built that way, that's how it will be built. So there's no point, they don't really look further into, well, what if, you know, kind of questions. And then there's a performance-based analysis, which is based around, okay, let's not prescribe so heavily how a building should be built. because that already kind of assumes that if you do it that way, it's safe. Why not go the other way? Let's look at, if we build it this way, then does the modeling tell us that that's safe? And if it doesn't, then obviously what changes can we make? And often architects are quite keen, and some civil engineers on that side, because it gives them a little more scope to design buildings the way they want them to. But it obviously does require the law to be on their side. If the law is very heavily down the side of you must follow regulations and that's it, then there's less scope for the modeling to be used prior to an incident occurring, and it would be more useful, unfortunately, after some fatal incident has happened to investigate what went wrong.
Thank you, Lynn. I also have a question. I wanted to know, from what you've explained, there's a lot of stages where you can look at simulation and human behavior and how to prevent tragic consequences of fire. However, even from my experience working at a private company, normally people just focus on the occupation element of it and don't really look at what happens even when you leave the building, where do you go or what happens, or even, what happens during the construction. It seems, disproportionate attention to that one area. I wonder if you have any thoughts on what are the main challenges, or why could that be, what could be needed so that we kind of amplify that view of the holistic view of fire safety?
Well, in the UK, unfortunately, it's taken a tragedy to do that. To then talk about what is described as a golden thread that goes through from beginning, design, construction, use, and even after it's out of use, after a building's been decided that it's met the end of its life. So unfortunately, that's one way, is unfortunately, it's just having deaths that highlights it. Obviously, we don't want it to be, to go as far as that before people start to pay attention to it. I think the design phase is probably going to be improved because of the rules around BIM. And that work is being done internationally. It's not just in the UK. So that's probably going to be used more. So certainly at the design phase, there may be more attention paid there. The construction phase, I'm not sure. The US is more proactive in terms of putting out statistics on construction fires. They've made that more available, and they are actually doing some work on that. And also, actually, in the US, I'm aware very much of all the different community work that's going on with wildfires. So I think at community level, it may be a bottom-up approach that might end up working out best. It shouldn't be left to the public to be basically taking things in their own hands. The government should be doing more. And I guess that falls upon us as researchers to capture the attention of the governments more. I think what we need to do in all of these things, and same with construction companies, is we need to give them incentive. We need to tell them why it's going to benefit them. Because I think often when we talk about it's going to help make people safe, I mean, it should be obvious what the benefit is there. But I think sometimes some of these parties are a little bit more self-centered, so they're looking for what can benefit them. So if you're going to conduct research in a construction site, they may be thinking, well, that takes away time from our job, and time is money. So we certainly found that with the work that we did when we first tried surveying people during breaks. They weren't happy. The workers weren't happy, understandably, because that was the only time they got downtime. But the firm wasn't necessarily happy that we did the surveying during their work hours either. So the best way we found was surveying them when they're at the assembly point outside. Gives you a small window to survey them, but you've got everyone's attention and you're not taking them away, because they'll do these as parts of fire drills anyway. So yeah, there's possibly some ways we can get things working better.
Thank you. There's one question from Juan Carlos Lopez Ojeda that I think is not necessarily for you, but it's just a question about whether there's any, or maybe you could tell, right? If there could be any model that specifically could be used for the volcano evacuation. Well, volcanoes very much on top of our heads now because of what is happening. It's very active now. So I guess there's one thing I know, that essentially there isn't a model that is used for evacuation from a volcano, just as usually there isn't an evacuation modeling from a wildfire in Europe. What the research that I've done, normally you would plan evacuation per plans, per available routes, and several scenarios. It's a very manual work. But Lynn, do you think, for example, urban exodus could be adapted to an event such as a volcano evacuation?
Yes, in short, I think it could, because it has shown it can be used across, as I said before, floods, as well as fires, as well as CBRN, spillages, and so forth. So I think there is the potential for it to be used for that as well. As I said earlier, if there are experts out there who can provide data on the behavior of the lava flow, and also eruption rates, basically work out how long people might have when they start seeing the first cues that there's going to be an eruption, that would be required. Also, that data would have to be compatible with the models, which is often what stops some of this work happening, or at least hinders it, is getting it in a format that can be used. But as I said, with the wildfire type work, you're taking in data from OSM, you're taking in data from all kind of different sources, just data is being used as well. So I think urban exodus, and there's also open source software that's being developed. I mean, ours is a commercial product. There are other open source models that are being developed for larger urban spaces as well. So there's a growing community that understand the need for this. And I'm sure that at least one of them, if not more, could be adapted for that kind of use.
Thank you so much, Lynn. That was the last question. And I'll give it over to Luis Enrique now.
Buenos días a todos. Doctora Lynn, Sandra, muy agradecidos por esta ponencia. Como siempre, Sandra trayéndonos ponentes de alto nivel con gran conocimiento. En esta ocasión no fue la excepción. Agradecidos a ambas por su participación. Continuamos con lo que es el otorgar los reconocimientos. Ya los tenemos aquí en pantalla. Para la doctora Sandra Lynn tenemos un reconocimiento por su participación en el capítulo SFPE México, que otorga el presente reconocimiento a Lynn Hulse por su exitosa participación como conferencista en SFPE Capítulo México con el tema Modelado de evacuación y cómo puede ayudar a construir un futuro más seguro. Firma nuestra actual presidenta Sandra Bauchelite y su servidor Luis Enrique Bernal. Celebrado día 25 de mayo de 2023 en la Ciudad de México. Como les habíamos comentado la vez anterior, si alguien desea o le interesa adquirir una constancia de participación para este evento, se lo podemos proporcionar, solo que tiene un costo por lo que nos genera el gasto de crear esas constancias, que es de 500 pesos moneda nacional. Si alguien tiene ese interés, por favor, escríbanos al correo de contactos @sfpemexicocharter.org. Y hoy también es un día muy especial, por lo cual hacemos un reconocimiento también del capítulo SFPE Mexico Chapter y se lo otorga a la doctora Sandra Bauchelite por su gestión como presidenta del capítulo México de la Society of Fire Protection Engineers, que fue durante el periodo de febrero de 2022 a mayo de 2023, celebrado el día 25 de mayo de 2023 en la Ciudad de México. Firma un servidor, Luis Enrique Bernal. Pues este día, lo especial que tiene es, Sandra, hacerte un reconocimiento a tu participación en esta gran gestión. El primer año de este capítulo fue todo un éxito. Hubo mucha audiencia interesada en los temas que nos trajiste, con los ponentes también. Y pues agradecer toda esa gestión y esa labor que has hecho para el capítulo. Contamos con tu participación que se seguirá dando, pero ya con otras actividades a lo que tenemos platicado y entendido. No sé si tienes unas palabras que nos compartas.
Muchísimas gracias, Luis Enrique. Yo solo quería tomar un minuto para agradecerles al equipo por su colaboración, su paciencia y de verdad mi tiempo con SFPE Capítulo México estuvo muy productivo y personalmente yo aprendí muchísimo de todos y todos ustedes. También me hace feliz saber, ¿no?, que hemos logrado muchísimo de ser inclusivos, mantuvimos balance de género, estuvimos abiertos, dimos bienvenida a todos, a muchísimos temas que recorre todo, ¿no?, de lo social, como educación, comportamiento humano, inequidades en protección contra incendios, hasta lo técnico, como estructuras, ¿no? Entonces, establecer esa gama fue lo más importante para mí, pero estoy 100% segura que hay muchísimas más ideas que SFPE Capítulo México presentará y seguirá innovando desde aquí adelante, ¿no? Entonces, gracias a todos y fue realmente un honor ser parte del Capítulo México SFPE. Muchísimas gracias.
Gracias a ti, Sandra, y
Gracias,
esperamos
Sandra.
verte pronto con alguna presentación o con tu colaboración.
Sí, cuentan con ello.
Muchas gracias. Muy bien, les anunciamos las actividades que tenemos próximamente. Para el mes de junio, el día 29, ya tenemos la charla o la ponencia del mes de junio. Va a ser el tema de mantenimiento y actualización de sistemas de protección contra incendio, desde el enfoque de cómo podemos visualizar si es un costo o una inversión. Nos lo va a impartir, va a ser en dúo, las ingenieras Jacqueline Hernández y ingeniera Dolores Orozco. Esperamos que este tema sea muy interactivo, que los participantes también durante la ponencia tengan participación y esperamos sea todo un éxito, los esperamos a todos. Y también tenemos el anuncio de lo que será nuestro congreso, por ahí tenemos algunos cambios. Las razones se las dará a continuación. Ricardo, si me puedes apoyar como organizador de estos eventos, te cedo la palabra si nos apoyas con información, de favor.
Gracias, Luis Enrique. Primero y antes que nada, quisiera agradecer personalmente a Sandra. Sandra, muchas gracias por todo. Gracias por tu participación, tu empuje, tu experiencia. La verdad ha sido una gestión inicial que superó por mucho los planes y las expectativas que teníamos y me quedo con un muy buen sabor de boca, con un agradecimiento enorme para ti y muchas gracias. Digo, nos seguiremos viendo, pero agradezco desde el corazón toda tu participación. Lynn, thank you very much. Ok,
Thank you very much.
bien. Originalmente teníamos programado para junio 4 y 5 en Querétaro el Fire Protection Congress. Sin embargo, por temas de logística y de los hoteles, se complicó la ciudad de Querétaro y se nos vino el tiempo encima, por lo que se tuvo que decidir en un cambio de sede. Y Tijuana levantó la mano para apoyarnos a través de los departamentos de bomberos y los gobiernos municipales y estatales, y se está cambiando para agosto 23 y 24, que es miércoles y jueves. También es atractivo para los que quieran aprovechar ya el fin de semana y poder ir a San Diego, a la zona ahí de California, pues también es muy interesante, o bajar a la zona de Ensenada y los viñedos y todo eso, ¿no? Vamos a llevar a cabo el evento el 23 y 24. En unos días más se va a abrir la página para las inscripciones, tanto a los temas como a los patrocinadores que gusten participar. Y bueno, promete un evento de mayor relevancia y muy importante para todo lo que es la SFPE Capítulo México e internacional, y además tendremos participación de SFPE Internacional ahí con nosotros. Es cuanto, Luis Enrique.
Gracias, Ricardo. ¿Podemos continuar con los slides? Bien. Les recordamos nuestras redes sociales donde pueden tener interacción y comunicación con nosotros. Les agradecería mucho los pudieran utilizar y nos pudieran hacer llegar todas sus inquietudes, recomendaciones de interés de algún tema para poderlo tomar en cuenta y que podamos cada vez tener más participación también del público en general. Se los recuerdo a través de LinkedIn como SFPE Mexico Chapter, en Twitter como @SFPE MX Chapter, en YouTube SFPE Mexico Chapter. Ahí en YouTube estamos subiendo los videos de las presentaciones que hemos tenido durante los eventos anteriores. Este actual del día de hoy, próximamente ahí lo podrán encontrar también. En Facebook como SFPE Mexico Chapter. Y antes de cerrar, me gustaría comentarles, como ya se habrán dado cuenta, a partir de esta fecha tomo el cargo y el reto como presidente y guía del capítulo para lograr los objetivos y metas que tiene el capítulo, pues requerimos del apoyo y la participación tanto de un comité directivo como de gente que participa en general, cada mes conectándose y siendo partícipe de los temas. Próximamente, la próxima sesión, les haremos partícipes de cómo queda el organigrama de esa mesa directiva. Esperemos tener participación y seguir los mismos lineamientos que a bien nos enseñó Sandra, en ser participativos, en dar la oportunidad a todos los que deseen participar y nos traigan cosas que aporten para bien a esta comunidad. De mi parte, gracias.
Un segundo, por favor.
Sí, claro. Adelante.
Sandra, por ahí tenías la palabra.
No, ya todo bien, Ricardo,
Ok.
ya la di. Gracias.
Bien, es que vi tu mano levantada. Bien, también aprovecho para felicitar a Luis Enrique por su nueva posición dentro del capítulo. Él venía desempeñándose también con mucho trabajo como vicepresidente. Y bueno, a partir de ahora que Sandra deja la presidencia, la deja con un gran compromiso Luis Enrique para seguir el ritmo que traíamos y sobre todo mejorarlo, como es la idea siempre. Entonces tienes una meta importante y por cumplir para desempeñar ese puesto que con muchas ganas sé que lo vas a hacer porque lo has estado haciendo como vicepresidente. Y también agradecer al ingeniero Francisco Cepeda por ocupar la vicepresidencia del capítulo. Y como bien decías, bueno, ya conformarás tu mesa directiva y como siempre lo hemos dicho y lo hemos respetado, ¿no? Y Sandra hace mucho hincapié y definitivamente es un hecho, la inclusión de géneros es muy importante para que se tenga en la mesa directiva participación importante en esta inclusión. Agradezco el compromiso que toman, tanto tú como Paco, y pues adelante. Gracias también, Francisco, ya sé que estabas, pero la cámara no. Te felicito y pues bueno, ahí tienen un trabajo importante por hacer. Muchas gracias a todos, a Luis Enrique y a Francisco, y de mi parte, pues bueno, también ahí ya saben que cuentan conmigo para lo que se necesite.
Muy amable, Ricardo, y sí, vamos a contar con el apoyo que siempre has dado para este capítulo. Extender la misma felicitación que le hicimos a Sandra, también fuiste parte importante en este periodo y lo serás para el nuevo periodo que comienza el día de hoy. Francisco, por ahí estás, ¿gustas tomar la palabra y también darnos algún mensaje?
Sí, pues nada más agradecer a todo el equipo el trabajo que se ha hecho durante este tiempo y bueno, pues ofrecer todo lo que podamos para poder ayudar y seguir creciendo en el capítulo aquí en México. Gracias, Sandra, por todo lo que nos has enseñado y bueno, pues vamos a seguir caminando juntos. Estoy seguro.
Muy bien, gracias, Francisco. Pues a trabajar. Si ya no hay más, cerramos la sesión agradeciéndoles a toda la comunicación, a toda la
Vamos,
comunidad
Sandra.
de participación. Un aplauso. Nos vemos la siguiente. Muchas gracias.
Gracias a todos los participantes. Gracias, Israel Solano, por ahí te veo. Gracias.